Hello students, today we will discuss the concept of beats and organ pipes. Now, what do you mean by beat? What do you mean by beat frequency? How the beats are produced and what are the condition for beats? Let us discuss about the things. When two sound waves of slightly difference in frequency moving along the same direction interfere, waxing and waning means maxima and minima frequencies of sounds are heard at regular intervals of time. This phenomenon is what we call beats. For example, let us see we have two waves whose displacements are y1 is equivalent to a sin omega 1t, which is equivalent to a sin 2 pi f1t. y2 is equivalent to a sin omega 2t, which is equal to a sin 2 pi f2t, where f1 f2 are the frequencies, where a is the amplitude. Here the two waves having same amplitude, their frequencies are f1 f2. Due to superimposition of them, the resultant displacement is y is equals to y1 plus y2, which is equal by adding them, taking a as common. This is sin something and sin something in the form of sin c plus sin d, which is 2 sin c plus d by 2 into cos c minus d by 2. So here using that formula, y is equivalent to y1 plus y2 can be simplified as 2a cos omega 1 minus omega 2 by 2 into t sin omega 1 plus omega 2 by 2 into t. So amplitude beat frequency is 2a cos omega 1 minus omega 2 by 2 into t. Here amplitude frequency is omega 1 minus omega 2 by 2. In terms of frequencies, omega 1 can replace by 2 pi f1, omega 2 can replace by 2 pi f2. So amplitude frequency is omega f1 minus f2 by 2. Now frequency of wave, which wave? Beat wave, which is equivalent to omega 1 plus omega 2 by 2. Nothing but omega 1 can replace by 2 pi f1, omega 2 can replace by 2 pi f2. By replacing them, frequency of beat wave is f1 plus f2 by 2. Therefore, these two formulae are most important. This is the formula for amplitude frequency. This is the formula for the frequency of the beat wave. Amplitude frequency of, this is the frequency of beat wave. When you compare these two, this is the frequency of beat wave is f1 plus f2 by 2. Amplitude frequency is f1 minus f2 by 2. In this comparison, we can say amplitude frequency always less than the frequency of this beat wave or resultant wave. Now here amplitude of beat wave, which is 2a cos omega 1 minus omega 2 by 2 into t, this value varies only with the time but not with position. So that means amplitude beat wave is only varies with the time but not with position. Therefore, when two sound waves of slightly difference in frequency moving along the same direction interfere, as a result waxing and waning are heard at regular intervals of time. What do you mean by that? Waxing, immediately waning, then again waxing, immediately waning means waxing alternatively, waning alternatively can be heard. Waxing means maximum, waning means minimum. So from the earlier discussion, we come to know that amplitude of beat frequency is a cos 2a cos omega 1 minus omega 2 by 2 into t. Intensity is equivalent to or directly proportional to square of amplitude. So by knowing amplitude, intensity I is equal to 4a square cos square omega 1 minus omega 2 by 2 into t. That is for intensity. So from this one, y I is equivalent to I proportional to a square, and 4a square, if you take this as I naught, this will become I naught cos square omega 1 minus omega 2 by 2 into t. Waxing means maximum, waning means minimum. So we need to find out the maxima minima intensities. So here for maximum value, this value to be maximum. Therefore cos square something value must be maximum, means that value cos of omega 1 omega 2 by 2 value must be plus or minus 1. If it is plus 1, then also become plus 1. If it is minus 1, then also this value become plus 1. Therefore this value must be equal to plus or minus 1. So this cos of something become plus or minus 1 for values of, in place of this we supposed to have 0 because cos 0 is 1. In place of this if you have pi, cos pi value minus 1, minus 1 square become again plus 1. So in place of this if you have 2 pi, therefore in place of omega 1 minus omega 2 by 2 into t, if we have 0 pi, 2 pi, 3 pi, 4 pi, etc., n pi, then this value become positive, means plus 1 or minus 1. On the whole this value become positive, means maximum. So in this case, if you take these two, t value becomes 0 into 2 by this one. And again if you take pi, t is equal to 2 pi by omega 1 is omega 2. T is equal to 4 pi by omega 1 is omega 2. Like this. So we know that omega is equivalent to 2 pi f. Substituting that value over here, 2 pi by omega 1 is omega 2 is also equivalent to 1 by f1 minus f2. This will become 2 by f1 minus f2. This will become 3 by f1 minus f2. Now we want to calculate the time interval between two successive waxing or maxima. If you subtract this from this one, what happens? 2 minus 1 by f1 minus f2, which is equivalent to 1 by f1 minus f2. If you subtract these two, 3 minus 2 by f1 minus f2, then also you will be getting 1 by f1 minus f2. Therefore, the time interval between two successive maxima is 1 by f1 minus f2. Similarly, for minimum value which is concerned to waning. So, this cos omega 1 minus omega 2 by 2 value must be 0. Therefore, t value is equivalent to this whole value must be equivalent to 0, means this whole value must be equivalent to 0, means omega 1 minus omega 2 by 2 into t must be pi by 2 because cos pi by 2 value is 0, or 3 pi by 2 or 5 pi by 2, etc. Now from this one, t is equivalent to, if you take pi by 2, 1 by 2 times of f1 minus f2. If you take 3 pi by 2, 3 times of 2 into f1 minus f2, and 5 by etc. Now we want to find the difference of timings between two successive. This is 3 minus 1, 2, 2 by 2 times of f1 minus f2, again 1 by f1 minus f2. 5 minus 3, 2 by 2 times of f1, again 1 by f1 minus f2. Therefore, the time interval between two successive maxima or two successive minima which is equivalent to 1 by f1 minus f2. That means, in the case of beat waves, alternatively maxima, minima periodically, means with regular intervals of time, can be heard by us. So here delta t is the time interval between two successive maxima or two successive minima which is equivalent to 1 by f1 minus f2. By knowing this, we can find out the beat frequency. Beat frequency delta n is equivalent to 1 by delta t, which is equivalent to f1 minus f2. That means beat frequency is the difference of frequencies between two sound nodes. There is one condition. So the maximum number of beats can be heard by healthy person is only 10. You cannot hear more than 10. Reason is that the persistence of hearing is 0.1 second. What do you mean by that? So we are able to distinguish the two sound nodes. If a minimum gap is 0.1 second, the minimum time interval between two successive sound nodes to hear them clearly is 0.1 second. Therefore, here delta t is equivalent to 0.1, delta n is equivalent to 1 by 0.1 become 10. Therefore, delta n value less than or equivalent to 10. Therefore, maximum number of beats can be heard by a healthy person, means that value always less than or equivalent to 10. Now, beat frequency delta n is equals to f1 minus simply difference in frequency of two sound nodes. Beat period, that is the time interval between two successive maxima or two successive minima, is delta t is equal to 1 by delta n, which is 1 by f1 minus f2. Beat period between waxing and immediate waning or waning and immediate waxing, which is equivalent to 1 by 2 times of delta n, which is 1 by 2 times of f1 minus f2. Now, combined wave frequency is f1 plus f2 by 2. Now, let us see one application of beats. This is the tuning fork. By filing the prongs of tuning fork, inertia decreases. Due to decrease in inertia, frequency increases. That means by filing the prongs of tuning fork, frequency increases because decrease in inertia. Similarly, by loading wax to one of the prong of tuning fork, what happens? Inertia increases. Due to increasing inertia, what happens? Frequency decreases. Slightly, not predominantly, just slightly decreases. So, due to filing the prongs of tuning fork, frequency increases. Due to adding a load like wax and so, the frequency decreases. This concept is required for further topic. There are two tuning forks. One is frequency of the first tuning fork is P, frequency of second tuning fork is Q. Suppose the frequency of P is greater than Q, then the beat frequency delta n is equivalent to P minus Q. If the frequency of Q is more than P, then delta n is equivalent to Q minus P. See here, the tuning fork, first one P, is filed. Due to filing the prongs of tuning fork P, frequency increases. No change in the frequency of Q. Then what happens to P minus Q? Let us take one example. Suppose P value 200, Q value 195 as P is more than Q. Suppose due to filing the prongs of tuning fork P, the frequency of 200 may increase from 200 to 201. So, earlier difference in frequency is 5. Due to filing the prongs of tuning fork P, frequency increase from 200 to 201, now the difference will become 6. That means the difference in frequency, beat frequency increases. Now, no change in P, only for a prongs of tuning fork it is a file. Due to file the prongs of tuning fork Q, what happens? The frequency of P is 200, Q is 195. By filing the prongs of tuning fork Q, this may increase from 195 to 196. Imagine. Earlier beat frequency was 5. Now the beat frequency is how much? 4. Therefore, beat frequency decreases. Now, by loading wax to the prongs of tuning fork P, what happens? So, before waxing load, the frequencies were 200, 195. By loading wax to P, the frequency of 200 may decrease from 200 to 199. Earlier difference was 5, but now the difference what happens here? Decreases. So, here earlier beat frequency was 5, now the beat frequency is 4. Therefore, in this case beat frequency decreases. Now, no changes made for P, but wax is loaded to Q. By loading wax to Q, what happens? Before loading a wax to Q, the frequencies were 200 and 195. The beat frequency was 5 for them. Now, when wax is loaded to Q, frequency of Q, which is 195 to it may become 194. Imagine. Now, earlier beat frequency was 5. Now, the beat frequency is 6. So, beat frequency increases. Now, if Q is more than P, all reverses. In this case decreases, in this case increases, in this case increases, in this case decreases. This concept is useful for us for solving the problems. Let us see one application. When two sound waves of wavelengths lambda 1, lambda 2, they produces beats together. How to find the beat frequency formula for them? See here, there are two sound waves whose frequency n1 is equivalent to V by lambda 1. One more wave frequency V by lambda 2. Their wavelengths are lambda 1, lambda 2. We want to calculate the beat frequency produced by these two waves. Delta n is equivalent to V by lambda 1 minus V by lambda 2. Taking V as common, lambda 2 minus lambda 1 by lambda 1, lambda 2. Therefore, using this, sometimes he may ask us to find the speed of sound even. By giving beat frequency, he may ask us to find the speed of sound. So, V is equivalent to what happens here? Delta n into delta n times of lambda 1, lambda 2 by lambda 2 minus lambda 1. So this is the formula to find out the speed of sound when beat frequency is given, which is V is equal to delta n times of lambda 1 minus lambda 1 lambda 2 by lambda 2 minus lambda 1. So beat frequency, the difference in frequency value f1 minus f2 value always less than or equivalent to 10. But it may not be always a fraction, it may not be always a pure number. Suppose the beat frequency, the difference in frequency delta n is equivalent to, we got 4.2 Hz. Suppose if it is a fraction, if delta n is equal to difference in frequency 1, 2, 3, okay, directly we can take. The difference in frequency is less than 10, we can say number of beats heard by a person is equal to 10. The beat frequency difference is more than 10, the number of beats is equivalent to 0. For example, n1 is equivalent to 200 Hertz and n2 is equivalent to 250 Hertz, imagine. The difference in frequency which is 50, which is more than 10. So in that case, number of beats is equivalent to 0, because maximum number of beats can be heard by a healthy person is always less than or equivalent to 10, since persistence of hearing is only 0.1 second. Suppose the difference in frequency is 4.2 like this. In this case, what happens? In the first second, he will hear only 4 beats. In the second second, he will hear again 4 beats only. In the third second, he will hear again 4 beats only. In the fourth second, he will hear 4 beats only. In the fifth second, he will hear 5 beats. Means when 4.2, 4.3 like that are given, we should not round off to nearest integer. So this is nothing but here in the first second 4 beats, second 4 beats, third second 4 beats, fifth second, fourth second 4 beats, and the fifth second no, here 0.2 left over no, that can be nearest integer round off nearest integer is 1. So therefore finally in the fifth second 5 beats are produced. That means here in the 5 seconds totally 4 4 the 16 plus 5, 21 beats are heard by a person in 5 seconds. So this is one of the important problem. 3 sources of sound produces same sound of same intensity whose frequencies are 400, 401, 402 Hertz. How many beats are heard from these sound waves? See, y1 is equivalent to a sin 2 pi. Actually we have the formula a sin omega t. A sin 2 pi of 400t. So from this one a sin 800 pi t, because frequency here is given as 400. When the frequency is taken 401, this y2 value become a sin 2 pi into 401, that will become 802 pi t. Similarly for a frequency of 402, this will become a sin 804 pi t. They superimpose each other. As we discussed in the superposition principle, the displacement of resultant displacement of 3 progressive waves is y is equivalent to vectorial sum of the individual y1 plus y2 plus y3. Using the relation a y1 plus y2 plus y3, by adding all these 3 equations, a sin 800 pi t plus 802 pi t plus 804 pi t. From this one, let us take 800 pi t, 804 pi t together. So that is sin c plus sin d. By applying sin c plus sin d, again formula 2 sin c plus d by 2 into cos c minus d by 2. Using that we will be getting 2 sin 802 pi t cos 2 pi t. Again here 802 pi t, here 802 pi t. We can take 802 pi t as common. Taking 802 pi t as common from both of them, a sin 2 pi t, you know that multiples of 2 pi. Again, so for example, we have sin 2 pi plus pi by 2 means sin pi by 2. Sin 4 pi plus pi by 2, sin pi, like that. So 802 pi, sin 2 pi taking as common. Otherwise 1 plus 2 cos 2 pi t. So here from this one y is y1 plus y2 plus y3, taking a as common, sin something. So from these two taking sin 802 pi t, sin 804 pi t together, applying the formula sin c plus sin d, that you know that sin c plus sin d, 2 sin c plus d by 2 cos c minus d by 2. Using that 2a will get 2 sin 802 pi t cos 2 pi t. Again from these two terms taking sin 802 pi t as common, 1 plus 2 cos 2 pi t. So here the resultant amplitude of this wave is A times of 1 plus 2 cos 2 pi t. From this one, when t is equal to 0, 1, 2, this cos 2 pi t value become maximum because t is equal to 0, cos 0 value 1. So like this, when t is equal to 1, cos 2 pi, then also 1. When t is equal to cos 4 pi, then also 1. So here resultant amplitude is A times of 1 plus 2 into 1. 2 into 1, 2 plus 1 become 3, 3A. So the time interval between two successive maxima, you see 0, 1, 2. 0 to 1 is 1, 1 to 2 is 1, 2 to 3 also 1. Therefore, time gap is only 1 second. Beat frequency how much? 1 by delta t is equivalent to 1. Therefore, the number of beats heard due to the three sound waves of 400, 401, 402 hertz frequency is only 1. So, sonometer, the last we discussed, frequency loss, n proportional to 1 by L, n proportional root T, n proportional 1 by root mu. So, those three laws can be verified by using sonometer. Now, let us see one problem how the sonometer linked with the beats. So, there is one more problem. A sonometer wire of length 50 centimeters produces 4 beats per second with a tuning fork, and on increasing the length to 51 centimeters again it produces 4 beats per second only. He is asking us to find the frequency of tuning fork. That means when the length of the string is equivalent to 50 centimeters, so here number of beats produced are 4 only. When the length is equivalent to again 51 centimeters, the number of beats produced again is equivalent to 4 only. We know that n proportional to 1 by L. So here from this relation we can say n1 by n2 is equivalent to L2 by L1. So here beat frequency 4 here, n plus 4 in one case, n minus 4 in one case is equivalent to L2 by L1, which is equivalent to 51 by 50. So here n and L, n1 by n2 is equivalent to L2 by L1. When the length is 51 centimeters, number of beats again 4 only. When the length is 50 centimeters, then also number of beats 4 only. So here let us consider n is the frequency of tuning 4. Therefore, n plus in place of n1 write n plus 4. In place of n2 n minus 4, because length increasing. So frequency has to decrease. Therefore, n plus 4 by n minus 4 is 51 by 50. On simplification, 50n plus 200 is equivalent to 51n minus 204. From this one, 51n minus 50n is equivalent to n 200 plus 204 is equivalent to 404 hertz is the frequency of given tuning fork. Now let us see about the organ pipes. What do you mean by organ pipe? A organ pipe is a cylindrical pipe which is having uniform cross-sectional area with air is trapped as a medium between them. So here these pipes, organ pipes are of two types. One is called open pipe, other is called closed pipe. Open organ pipe is nothing but the pipe which is open at both the ends is what we call open pipe. The pipe which is open at one end, other end is closed, is called as a closed pipe. In the case of open pipe, suppose say this is the open pipe, a longitudinal progressive waves are set and forms a stationary waves. So here this is a closed pipe, this is open end, this is a closed end. At the closed end, always displacement node will form, pressure antinode will form. That means in the case of closed pipe, this is called as pressure wave, this is called displacement wave. So this is the position of displacement node, this is the position of pressure antinode, because the reflection takes place from the closed end. So in the case of longitudinal waves, as we discussed earlier in the reflection of waves, the pressure wave, if it is a longitudinal wave, reflection takes place from the closed end, the phase change is equal to pi radians. So what happens here? This is the position of antinode. So therefore, this is the position of pressure antinode, this is the position of displacement node. When a longitudinal wave, reflection takes place from the fixed end, the delta phi is equivalent to 0, phase difference is equal to 0. That means compression reflects as compression, rarefaction reflects as a rarefaction. So here, due to which in this case, this is the position of pressure antinode, this is the position of displacement node. So here at a position of pressure antinode, the pressure change is maximum. Pressure change is maximum means the molecules over here have more pressure. Due to this, what happens? Compression reflects as compression, rarefaction reflects as a rarefaction. So, in the case of closed pipe. Now, in the case of open pipe, what do you mean by open pipe? The pipe which is open at both the ends is what you call open pipe. At the open end, always displacement antinode will form and pressure node will form. So, here this is what you call displacement wave. So, this is the position of displacement antinode and this is the position of pressure node. So, here at the open end, what happens? The molecules have low pressure. Due to low pressure, all the surrounded molecules nearer the pipe will move toward the closed end, and what happens here? This compression reflects as a rarefaction, rarefaction reflects as a compression, due to which this is the position of pressure node or displacement antinode. So, now let us see, when a longitudinal progressive waves are propagating through a closed pipe, open pipe, how the standing waves are formed. Suppose say this is the closed pipe, one wave is introduced, longitudinal progressive wave is introduced into the closed tube, reflection takes place from here, this is displacement wave, the length of tube is equivalent to L, imagine. This is the antinode position, this is a node position of displacement wave, antinode to node is equivalent to lambda by 4, from this one lambda is equal to 4L, we want to find the frequency, N is equivalent to V by 4L. This is called fundamental frequency. In the second mode of vibration, so this is what we call displacement node form over here, displacement antinode will form over here. In the second mode of vibration, the length of tube L is equivalent, this is lambda by 4, this is lambda by 2, lambda by 2 plus lambda by 4, together 3 lambda by 4, from this one L is equivalent to 3 lambda by 4 and the frequency N1 is equal to 3V by 4L. This is called as the frequency of third harmonic, or other name it is called as the first overtone. That means frequency of third harmonic is equivalent to frequency of first overtone in the case of closed pipe. Now, in the next mode of vibration, the length of the tube L is equivalent to lambda by 2 plus lambda by 2 plus lambda by 4. This whole value become L is equivalent to 5 lambda by 4, lambda is equivalent to 4L by 5. Again, the next higher frequency is N2 is equal to 5V by 4L. Therefore, fundamental frequency V by 4L. Next, third harmonic is 3V by 4L. Fifth harmonic 5V by 4L. Here, second, fourth, sixth, eighth are absent. Here, first overtone is 3V by 4L. Second overtone is 5V by 4L. Now, similarly, frequency of nth harmonic is N times of V by 4L. Frequency of nth overtone is 2N plus 1 times of V by 4L. So, in this case, the maximum wavelength of the wave is lambda is equivalent to 4L, because in this case, lambda L is equivalent to lambda by 4. Using this, we can say lambda is equal to 4L. This is the maximum possible wavelength of a wave in the closed pipe. Now, let us see open pipe, how the standing waves are formed in the closed pipe, open pipe. Open pipe is nothing but the pipe which is open both the ends is what we call open pipe. See, when a longitudinal progressive wave is sent to the open pipe, what happens here? This is what we call open end, this is also open end. So, here displacement antinode, this also displacement antinode will form over here. The length of the pipe is equivalent to this is a displacement node, this is displacement antinode, this also displacement antinode. Node to antinode is lambda by 4, node to antinode lambda by 4, on the whole this value become lambda by 2. So, L is equivalent to lambda by 2, from this lambda is equivalent to 2L, we want to find the frequency N is equivalent to V by 2L. In the second mode of vibration, this is the antinode position, this is node, this is node, this is antinode. Remember that at the open end always antinode will form, at the rigid end or the closed end always node will form. This is about the pressure, this is about the displacement. For displacement, node will form at the closed end, displacement antinode will form at the open end. Now, distance from here to here is, this is lambda by 4, this is lambda by 2. On the whole total length is lambda. Now, in this case frequency 2 times of V by 2L. In the next higher mode, this is antinode position, this also antinode, L is equivalent to 3 lambda by 2. So, the frequency 3V by 2L. Therefore, the fundamental frequency in the open pipe is V by 2L. This is called frequency of second harmonic. This is called frequency of third harmonic. Similarly, the frequency of nth harmonic in the open pipe is equal to n times of V by 2L. N times of V by 2L. Now, what about the overtone? In this case, this is 2V by 2L, nothing but a first overtone. 3V by 2L is nothing but a second overtone, and so on, so on, so on. Therefore, here the frequency of the overtone, nth overtone, n plus 1 times of V by 2L, because the n always the overtone number always greater by 1 with the harmonic number. This is how the frequencies of the ratio of the open pipe and closed pipe can be calculated. In this case, frequency ratio is 1:3:5:7, so on, so on. In this case, frequency ratio is 1:2:3. In the case of the closed pipe, frequency of nth harmonic NV by 4L. In the case of open pipe, frequency of nth harmonic is NV by 2L. In the case of open pipe, frequency of nth overtone is 2n plus 1 times of V by 4L. In the case of open pipe, frequency of nth overtone is n plus 1 times of V by 2L. So, this is the basic concept about the frequencies about the open and the closed pipe. Let us see end correction. So, due to inertia of motion of the particles, suppose say this is open pipe. Due to inertia of motion of particles, the displacement antinode will not form exactly at the end of the pipe or mouth of the pipe. That will form little bit above height than the pipe mouth of the tube. The distance between the mouth of the pipe or end of the pipe to the actual antinode position is what we call end correction. I repeat again, due to the inertia of motion of the particles, the antinode will not form exactly end of the pipe, that will form little bit above than the mouth of the tube or end of the pipe. The distance between actual end of the actual antinode position to the end of the pipe is what we call end correction. In the case of open pipe, it has two end corrections. One is over here, this is E and this is E. The end correction value E can be calculated using the formula E is equal to 0.3D, where D is the diameter of the tube. So, which is also equivalent to 0.3 into D is equivalent to 2R is equivalent to 0.6R is the end correction for the open pipe for general case. In the case of open pipe, what happens? Open pipe has two end corrections. Therefore, for open pipe, this end correction is equivalent to 2E because it has two open ends. In the case of closed pipe, what happens? It has only one open end. Therefore, it has only one end correction. This end correction E is equivalent to 0.3D. And we know that the fundamental frequency of the open pipe is N is equivalent to V by 2L from earlier discussion. Now, this is equivalent to V by, this complete length is nothing but a actual length of the pipe is L plus this end correction E, together the total length can be written as L plus 2E. So, V by total length is nothing but a, so here what happens? This complete length is equivalent to L plus 2E. L plus 2E is equivalent to lambda by 2. From this lambda is equivalent to 2 times of L plus 2E. We want to find out the frequency. N is equivalent to V by lambda. So, V by lambda is nothing but 2 times of L plus 2E. So, this is the formula to be used to calculate the fundamental frequency of the open pipe in the first mode of vibration when end correction is taken into consideration. Similarly, for the closed pipe, for closed pipe what happens? This is the total length. From here to here is length of the pipe is L. This is end correction. Therefore, for this is what we call closed end means antinode will form, node will form, at the open end antinode will form, node to antinode which is equivalent to lambda by 4 is the distance, which is equivalent to L plus E. From this one lambda is equivalent to 4 times of L plus E. Now, we want to find the fundamental frequency of this one. So, N is equivalent to V by lambda. So, V by in place of lambda, we can replace this with 4 times of L plus E. So this is the formula for the fundamental frequency of the closed pipe when end direction is taken into consideration. This is the formula to find the fundamental frequency of the open pipe in the case of the fundamental mode when the end correction is taken into consideration. So let us see one problem. There are two pipes. This is open pipe, this is closed pipe. Both of they have same length. The length of open pipe is L, length of closed pipe also L. Let us see both are in the fundamental mode of vibration, how their frequencies are related to each other. Now for open pipe we know that N is equals to V by 2L. This can be written as 2 times of V by 4L. V by 4L is nothing but a fundamental frequency of the closed pipe. V by 2L is nothing but a fundamental frequency of the open pipe when they have same length. So this V by 2L can be written as 2 times of V by 4L. We know that V by 4L is the fundamental frequency of the closed pipe having length L. Therefore, V by 4L can be replaced by frequency of the closed pipe. Therefore, NO means frequency of open pipe is equivalent to 2 times of frequency of closed pipe. This is how this open pipe closed pipe frequencies are related when they have same length. That means when a closed pipe converts into open pipe, that means this end is closed. By opening this closed end, what happens? The frequency of the same frequency of the same tube will get double. This is how the frequencies of open pipe and closed pipe are related to each other. So let us discuss one problem. The length of two open pipes are L and L plus delta L. So we have two pipes, one length of the pipe is equivalent to L and one more pipe length is equivalent to L plus delta L. We have two pipes of length. The length of two open pipes lengths are L and L plus delta L. V is the speed of sound. Suppose the speed of propagation of longitudinal waves is equivalent to V. V is the speed of sound. Now he will ask us to find out the beat frequency, that how can we calculate. So beat frequency in the fundamental mode, imagine. So this is the fundamental mode. Now here beat frequency delta N is equivalent to N1 minus N2. So here N1 is equivalent to, for the first case, V by 2L. In the second case, V by 2 times of L plus delta L. So here we need to find the difference of this frequency, that we will get beat frequency. So here from this one taking V by 2L as common, 1 minus of, from this one taking this one as L as common. So here 1 plus delta L by L power minus 1, which is equivalent to V by 2L times of 1. So using binomial expansion, minus of minus 1 over here into 1 plus delta L by L. Beat frequency delta N is equal to N1 minus N2. N1 is equal to V by 2L for this pipe in the first mode whose length is equal to L. N2 is equal to V by 2 times of L plus delta L, because the length of the second open pipe is L plus delta L. Now here taking V by 2L as common, 1 minus, here L plus delta L can be written as taking L outside, 1 plus delta L by L. And 1 plus delta L by L taken to numerator, that will become 1 plus delta L power minus 1. So using binomial expansion, this will become 1 minus, so here we can write minus 1 minus of 1 into delta L by L, which is equivalent to V by 2L times of 1 minus 1 plus delta L by L. So from this one 1 gets cancelled. So here V delta L by 2L square. So delta N is equals to V into delta L by 2L square is the formula used to calculate the beat frequency of the two pipes when the slightly different length by delta L. When the open pipe is like the length is equal to L, this L is equivalent to lambda by 4 plus lambda by 4 become lambda by 2. Fundamental frequency N is equivalent to V by 2L. This is the fundamental frequency. Now when this pipe is half immersed means up to this position, this is kept inside the water. When this is kept inside the water, this upper portion will behave as a closed pipe. That means in the fundamental mode, then the new length is only L dash. As it is mentioned in the problem, half is immersed in liquid water. Therefore, L dash is equivalent to L by 2. But as it is in the fundamental mode, the frequency is equivalent to, we know, V by 4 L dash, where L dash is the new length. So here V by 4 times of L dash means L dash is L by 2. So here L by 2 gets cancelled, is equivalent to V by 2L. So in this case what happens? When open pipe of length L, if it is in the fundamental mode of vibration, frequency N is equal to V by 2L. If it is half immersed in liquid, then the frequency remains N dash is equivalent to V by 2L, same as that of the N. So fundamental, one more problem, see, fundamental frequency of open pipe is F0, closed pipe is Fc. If they join to form a closed pipe in fundamental mode, he is asking us to find the fundamental frequency. That means, let us consider this is one open pipe, this is the fundamental mode vibration, the length of this pipe is equivalent to L1. So here N1, or in this case F0 is given, F0 is equivalent to V by 2L1. This is the fundamental frequency in the open pipe. So from this one, L1 is equivalent to V by 2FO or F0. Similarly, this is the closed pipe whose length is equivalent to L2. This is in the fundamental mode. In this fundamental mode, Fc is equivalent to, we know, 4L2. Their lengths are not equal. So Fc is equivalent to V by 4L2. From this one, L2 is equivalent to V by 4 times of Fc. I repeat again, in the case of open pipe, if it is in the fundamental mode, F0 is V by 2L1, L1 is equivalent to V by 2FO. Now in the case of closed pipe, let the length of this closed pipe is equivalent to L2. If it is the fundamental mode, Fc is equal to V by 4 L2, L2 is equal to V by 4 Fc. Now what is in the problem? When they are joined to form a closed pipe, means these two pipes are joined together. Means now this will become a closed pipe. So here, now the length of this pipe is L dash is equivalent to L1 plus L2. L1 plus L2 become the new length of the closed pipe. Now this is in the fundamental mode, it is in vibration. So here, in this case, we want to find the frequency of this in the fundamental mode. That how can we calculate? We know that in the fundamental mode, F is equivalent to V by 4L is where L dash is the new length of this closed pipe. Now we want to find the L dash value. What is L dash value? L1 plus L2. So therefore, F is equivalent to V by 4 times of this L dash is nothing but L1 plus L2, which is equivalent to V by 2FO plus V by 4 Fc. So the simplification of this is taking V as common, V therefore the frequency of this closed pipe in the fundamental mode is F is equal to V by 4 times of V by 2F0 plus V by 4 Fc. So we have to simplify that. So F is equivalent to V by, taking V as common. Here already we have 4, V gets cancelled. 1 by 2FO plus 1 by 4 Fc. Now taking LCM, 1 by 4 times of 2FO 4 Fc, 4FO Fc, 2FO goes here 2 Fc times plus 4 Fc goes and here only F4 times. Therefore 4 gets cancelled, which is equivalent to FO Fc by FO plus 2FC. This is the frequency of the so formed closed pipe by the combination of these two in the fundamental mode. Yeah, now let us see one more problem. A closed pipe of length L is vibrating in its third overtone, that is seventh harmonic mode with maximum amplitude A, and maximum displacement amplitude is A. The amplitude of vibration at a distance of L/7 from its closed end. See, this is the pipe which is closed pipe, some length is equivalent to L. He is asking us to calculate the displacement amplitude at a distance of L/7 from the closed end, which is nothing but a standing wave form. We know that standing waves are produced, stationary waves are produced in closed pipe. We have the formula, general formula, A is equal to 2A sin kx, because reflection takes from a closed end. So we have to use sine function 2A sin kx. So 2A sin k is equal to 2 pi by lambda. At what distance you want to calculate? At a distance of L/7 from closed end. So in place of x, substitute L/7. I repeat again. So standing waves are formed in the case of closed pipe, and the reflection takes place in the rigid end. So amplitude is 2A sin kx, 2A sin 2 pi by lambda into x value L/7. On using this value 2A sin 2 pi by lambda value. How to calculate lambda value? To find the lambda value, here this is third overtone, means seventh harmonic. The complete length is equal to L. From here to here lambda by 2, this is one more lambda by 2, one more lambda by 2, final lambda by 4. The total length L is equal to how much here? 7 times of lambda by 4. Therefore, this L/7 is there, L/7 as it is, lambda value we got from this one as lambda by 4. So lambda by L/7 value here, lambda value 4L/7, 4L/7, L/7 gets cancelled here, 2 pi by 4. This 2 pi by 4 is sin pi by 2, sin pi by 2 value 1. 2A into 1 is equal to 2A, means which is the maximum amplitude, which is given the problem as A. Therefore, at a distance of L/7 from the closed end, this is called displacement amplitude, which is equivalent to maximum amplitude, which is equivalent to A. Now let us see one problem concerned to open pipe and closed pipe. See, frequency of third overtone closed pipe is equal to the frequency of fifth overtone the open pipe, and the length of pipe, open pipe, closed pipe is given. He is asking us to find the length of open pipe. See, for closed pipe, 2n plus 1 into V by 4L is the third overtone in the case of the closed pipe, which is equivalent to 7 times of V by 4 times of LC, where L is the length of the closed pipe. Here in the problem he mentioned, for open pipe n plus 1 into V by 2LO is the frequency of the open pipe. He gave that n value as 2 because he gave the fifth overtone. So n is equivalent to 5, 5 plus 1 is equal to 6 V by 2LO. Both are in the same frequency, both are in resonance, means both together vibrate the same frequency. That is nothing but a 7 V by 4 times of LC for a closed pipe is equivalent to 6 V by 2 times of L for the open pipe. Now, in the problem, length of the open pipe is given as 5 centimeters. Let us substitute this value over here in place of LO as 5 centimeters. Now we can find out the length of closed pipe as LC is equivalent to 7V, here VV gets cancelled over here. Therefore, 2 goes 2 times. Now we would like to find out the L of the length of the closed pipe. Here VV gets cancelled, 2 goes 2 times. So LC, length of the closed pipe, we need to calculate. Length of open pipe is given as a 5 centimeters. Therefore, length of closed pipe is equivalent to 7 by 2 times of length of the open pipe. Length of open pipe is given as a 5 centimeters. So 7 by 2 into 5, 7 5 is 35, 35 by 2 centimeters, which is equivalent to 17.5 centimeters is the length of the closed pipe according to the given condition of the problem. Now let us see one problem how the sonometer linked with the beads. This is a string of length L which is fixed both the ends. It is vibrating in the fundamental mode. Therefore, fundamental frequency F0 is equivalent to V by 2L because L is equivalent to lambda by 2 over here. Frequency N is equivalent to V by lambda. You will be getting V by 2L is the frequency. Now, a triangular movable bridge is introduced at a distance of delta L from the middle, so that at either ends it is vibrating the fundamental mode. That means when you introduce a triangular bridge at a distance of L by 2 minus delta L from left end or L by 2 plus delta L from right end. So when at these two places they are in the fundamental mode. Therefore, frequency of the first part is F1, frequency of second part is F2. F1 is equivalent to general formula V by 2L only. V by 2 times of this length will become how much? L by 2 minus delta L. Therefore, V by 2 times of 1 by L by 2 minus delta L. Now, the fundamental frequency of the right side part of the string will become V by 2 times of 1 by L by 2 plus delta L. Now, we want to find out the beat frequency. Therefore, delta F is equivalent to F1 minus F2, which is equivalent to V by 2 times of 1 over L by 2 minus delta L minus 1 over L by 2 plus delta L. After simplification of this, taking LCM of these two, L square minus 4L delta L square by 4. L plus 2 delta L minus L minus 2 delta L. On simplification of this, V by 2 times of 8 delta L by L square minus 4 delta L square. We know delta L is very least. When you compare the delta L with respect to L, no, delta neglected. Neglecting delta L value, you will be getting V by 2 times of 8 delta L by L square. But F0 is V by 2L. Substituting V by 2L value as F0, you will be getting 8 F0 delta L by L. So, this is the beat frequency in the case of the sonometer under this special case.